students. So I will be again talking about photocatalysis today. Now we all know that sunlight and water are the most abundant, clean, renewable and natural source. So they are abundant, clean, renewable natural source. And their conversion to hydrogen is described as an ideal solution to counter all the environmental issues associated with fossil fuels. So, if we could somehow convert this sunlight and water into hydrogen, so that will be a very good answer to the depletion of fossil fuels that is going on. Now, to do this, TiO2 or a photocatalysis takes a major role. And TiO2 is the most used photocatalysis. It was first used in 1972, introduced to the world as a photocatalyst by Fujishima and Honda. Now, we will not concentrate on sunlight, rather we should be concentrating on water, how to produce hydrogen from water, and the process is called water splitting. Water splits and forms your hydrogen. And this phenomena takes place in a cell called photoelectrochemical cell, or in short it is called PEC cell. Now, when this cell, what happens is that there is generation of electron and hole pairs, and there is formation of O2 minus and H plus. So you can see that there is an formation of electron and hole pairs in these materials. Now, water splitting when occur when there is a certain potential of any reaction of the splitting, when this potential is higher than the minimum potential required to overcome the system losses. This is basically a thermodynamic definition. When the potential of any reaction is higher than the minimum potential to overcome the system losses, then that reaction becomes feasible. Now, in general, the hydrogen generation by photocatalysis or photocatalytic water splitting can be divided into two types. Two types of catalytic water splitting. The first one is called photochemical cell reaction. And the second is called photoelectrochemical cell reaction. Now, in a photochemical cell reaction, so we'll talk about photochemical. Photochemical cell reaction, the photocatalysis or the photocatalyst, which can be a TiO2 also, the photocatalyst, it is present as suspended particles in the solution. And there are certain parameters which needs to be taken care of, like light absorbance, instantaneous substrate concentration, and pH. Rather, pH change which occurs as a reaction process. Now, why these parameters are important? Because these parameters will govern the kinetics of the reaction. Now, to increase the photocatalytic activity of TiO2, usually we add a metal to a TiO2. Now, the advantage of adding a metal to TiO2 is a metal usually it will attract electron towards itself, and due to this attraction, the rate of recombination of the electron hole pairs, recombination rate of the electron hole pairs, it gets lowered due to this tendency of the metal to attract electron. And normally we can use silver in TiO2, and it is impregnated as silver ions, and Ag plus ions are impregnated on the surface of the TiO2 catalyst. So a compound or a composite of these two materials can form. Now, there are certain advantages and disadvantages associated with TiO2 being used as a photocatalyst. So, we will first tell you the advantages. First of all, TiO2 possesses high photochemical stability. Stability is high in case of TiO2. The second advantage is it is environmental friendly. Second is it is stability against photo corrosion. The fourth one is it is non-toxic. The fifth one is it is abundant. And the sixth one is can be produced easily in nano form. So putting it in nano form usually increases the activity of the photocatalyst because of a higher surface to volume ratio, and this nano TiO2 or nano TiO2 can be obtained by simple soft chemistry methods like sol gel. So these are the advantages. Coming to the disadvantages. Okay, of TiO2 being used as a photocatalyst. First of all is the recombination rate is usually high of the electron hole pairs. So recombination rate of the electron hole is usually high, which is detrimental towards photocatalysis. Second is it has got a wide band gap. The band gap is high, more than 3 electron volt or even more than that. So due to this high band gap, the use of TiO2 in the visible region becomes limited. Visible region use, it becomes limited because usually for higher band gap of this range it is more active in UV light. And the third is there is a large overall potential for hydrogen evolution on TiO2 surface. So the potential for hydrogen evolution is actually high on TiO2 surface. These are the three disadvantages.